Right, here we go. Next in our series of live streams on how to revise for your GCSE and IGCSE exams this year. This is the Boost 8 to 9 section on measures and estimation. And right on the wrong page. So we're going to start off with this question, which at level 8, 9 should be reasonably straightforward. And I'm going to give you a minute. This one, go. Okay, so we're going to find the upper bound for the area of this trapezium. Now, unlike this level 6 or 7, I'm going to show you the noddy way of making sure you get the right bounds. I'm going to assume you can find the right boundaries, and it's all about how you put them in to the problem. So we're going to look for the upper bound. So we know that the area, right pen, so we know that the area is equal to the height here. And if we make this equal to A and this equal to B, times A plus B over 2. And we're doing upper bound, so the height, to make the area as big as possible, we want H to be big, A to be big, and B to be big. So the upper bound of 3 to the nearest centimetre is 3.5. The upper bound of A to the nearest centimetre is 6.5. And the upper bound of B, nearest centimetre, is 7.5. And if you're struggling with boundary values, then go back and have a look at the stream on level 6 or 7 on this. So we're going to work that out, and that comes out to be 24.5. We do add these together, so that's going to give me 15 times by 3 divided by 2, so it's 7 times 3.5. That gives you 24.5. And to the nearest centimetre, that is equal to 25. So our answer we would put is 25 centimetres squared. Generally on the GCSE questions, though, you give the exact answer as your answer. So here we go. This one will take a little bit longer, a bit more to it. So I'll give you 2 minutes. It's not really a 2-minute question, but I'll give you all that. So there we go. That's that question. We're going to go through this now, and we're looking to find the lower bound for the length of the hypotenuse. So highlighter on. So we know that the hypotenuse h squared will equal 4.5 squared plus 7.2 squared, but we want the lower bound. And to make this as small as possible, we want the lower bounds of these. So the lower bound of 4.5 to 1 decimal place is 4.45 squared. The lower bound of 7.2 is 7.15 squared. So put those into our calculator. 4.45 squared plus 7.15 squared gives you an answer. And that gives you 70.925. And then we square root the answer. And we get the hypotenuse. 8.421. 8.421. And so on. Now remember what I said. In a GCSE exam, you generally get asked to put down the whole of that. Here it's being asked around to 1 dp, so we would get 8. Here. Right, here we go. And I think, see how long I said for this question. We're going to give you 2 minutes to have a go at this one. Okay, here we. Sorry, just lost the picture there somewhere. There we go. Right. Here we go. So we've got the volume of this sphere is 880 centimeters cubed round to the nearest 10 centimeters. But first of all, you need to know the volume of a sphere. And generally on the GCSE, they will give you this formula on the question. But it's 4/3 pi r cubed. You should really know all your formulae anyway. And we know the volume is 880 to nearest 10 centimeters. The upper bound will be 885. If you want to find the upper bound, we want to make the volume maximum to make the radius maximum. So equals 4/3 pi r cubed. So you've got 885 divided by 4/3 pi is equal to r cubed. Grab our calculator. And we do 885 divided by, open brackets, fraction for the 4/3 times shift pi, and close the brackets, get that value. That's 211.27. Remember always to keep 211, wasn't it? 211 point whatever is equal to r cubed. Keep all the numbers in your working. And now what we're going to do is going to cube root that answer to get r cubed. So cube root the answer, and you get 5.95595. 5595 and so on. And again, remember in GCSE you'd have to put that whole number, but here we're going to put the answer to the nearest one decimal place. Well, we've got to round up because that's 5, so that will round that up, so that will round that up to 6.0 if you're rounding to the nearest 0.1 centimetre. Okay, so we step these up into longer problems now, and I'm going to give you 3 minutes to have a go at this one. Just give your answer in kilometres per hour. Okay, let's look at this. Pour myself a bit of space. So Saturn's the largest of the moons, and the orbital radius on the moons is 1.105 kilometers. Now, this is probably was a little tricky to get this done in 3 minutes, so we need to work out the distance it travels through. So we need to work out the circumference of this. So we're going to have the circumference will equal 2 pi r. And we know that the speed will equal the distance over the time. And the distance is 2 pi r. Now, looking for the upper bound, so we want the distance over time. To find the upper bound, we're going to use distance max over time min, because that will lead to the biggest values when you divide these. So if we're looking for the upper bound for the speed, so I'm going to do the upper bound, and the distance will be equal to 2 times pi times the radius, which is 1. Now the upper bound of this is going to be, if it's to 2SF, it's going to be 1.95 times 10 to the 5. And the lower bound for 0.9 days to nearest 0.1 days is 0.85. And we want to convert that to hours, so we times that by 24. And then we put that in the calculator. So we get 2 times 1.95, use the XP button here, times 10 to the power of 5 equals, and we're going to divide all of that by 0.85 times 24, and that gives me 60,059. And so on. But we only need to give it standard form correct to 2SF. The correct to 2SF, this is going to be 6.0. We move the decimal place 1, 2, 3, 4. So that's times 10 to the power of 4. Do the lower bound similarly. So that's still going to be 2 times pi, but now the lower bound will be 1.85 times 10 to the 5 all over 0. Now we want the maximum time, which is 0.95, the upper bound of that, times 24 still. And effectively we do the same bit. We can't do the answers. I'm going to clear that all. 2 times pi times 1.85 is 5 divided by open brackets times 24. The 50,981. Obviously, you would give all the numbers if you're doing a GCSE 2SF. That's going to be 5.1. This third figure is 9, so we're going to round that up to 1 times 10 to the power of 1, 2, 3, 4. Is our answer, and these are both in kilometers per hour. Right, next question. Another 3-minuter. Off you go. Okay, let's have a look at this. So we're going to look at the lower bound of the original, which is going to be 11, right pen, 11.5 kilometers per hour. And the upper bound of this is going to be 12.5 kilometers an hour. Lower bound of the final speed is 22.5 kilometers an hour. And the upper bound is 23.5 kilometers per hour. And if we're assuming the acceleration is constant, we've got 6 seconds. So the time is going to be between, I'll show you my noddy way of working out boundary values, between 5.5 and 6.5 seconds. So we want to find the interval for the acceleration, what could be the highest and lowest. So to find the max acceleration, we're going to take the upper bound of the final, 3.5, and we're going to subtract to that the lower bound of the starting speed. And then to make that as big as possible, we want to divide by the smallest time. So that gives me 12 over 5.5. And to convert that into an improper fraction, we need to get rid of the 0.5 on the bottom. So we times by 2. So we get 24 over 5.5 times 2 is 24 over 11. Yeah, improper fraction. Now we want to do a min. That's going to be 22.5. Lowest value there, but we want the highest value, the original, minus 12.5. And then we want the biggest speed to make this the smallest. We divide by a bigger number, we get a smaller answer. So that gives me 10 over 6.5. And we times that by 2, we get 20 over 13 as an improper fraction. Okay, last question. Another 3-minuter. Off. Go. Okay, so let's have a look. To calculate the centripetal acceleration A, we square the velocity and we divide by the radius r. That's v squared over r. And what we want to do is find the upper and lower bounds for a rounded to the nearest whole number. So we're going to do, let's start off with a max. And that's going to be equal to v max squared over r min. We're going to use the lower bound of the of r. So v max, if that's the nearest whole number, is going to be 20.5 squared. And if it's just nearest 10 centimeters, the next one up will be 1.4 meters. So therefore, it's going to be 1.35 that we divide by here. And that's 20.5 squared divided by 1.35 gives us 311.29. I just want to check that because it's slightly different to what I got previously. Maybe I made a mistake before. And I have made a mistake because I'm looking for the upper bound and I've not divided by r min. Sorry about that. So the r min is 1.25 on the bottom. So if we go back and change that to 2.5, you'll see that we get 336.2. 336. 2 to the nearest whole number is 336. For a min, we got v min squared over r max. Make that as small as possible, so we want 19.5. Next value down, boundary value, and then we're going to divide by 1.35. This time that'll be right. So let's just go back and change these 19.5. Let's cancel it. 19.5 squared divided by 1.35 gives us 281.6 recurring. 281.6 recurring. So to the nearest whole number, this 6 will cause us to round this up. That is going to be 282 meters per second squared. That will conclude what we do on number work for our revision series. I'm going to be starting and working on algebra from next week. Thank you very much.